Welcome back everyone to another video in our structural engineering course. In this video, we are going to learn about stability and determinacy of beams and frames. Stability of structures is determined by the ability of the structure to withstand any certain load's configuration without moving or having excessive displacement. For example, let's check this beam here. As you can see, we have three supports with three reactions, but the three reactions, all of them are vertical in this direction, and we don't have any support in the other direction or any reaction in the horizontal one. So if you check this force here, it has a vertical component and a horizontal component. The vertical component could be resisted by this reaction here, but the horizontal component doesn't have any reaction, which means that the beam will start moving in this direction, of course ignoring the friction between the roller and the beam. Here, this is another condition also for an externally unstable beam, and we will explain what is the difference between externally and internally. Here you can see that all supports points are interacting at the same point, all of the reactions, as you can see here. This means that after you apply any force here, this beam will start moving in this direction, and here it will start moving in that direction. So it will not be stable also, and it is considered as externally unstable beam. In general, a beam is considered to be externally unstable in the following cases: if all reactions are parallel or if all reactions are concurrent. But this is the first type of instability, which is the external unstable beams. So what about the internally unstable beams? Let's check this beam here. As you can see, we have reactions horizontally and vertically. So it's not like the other beams which we have just checked few seconds ago. Also, not all reactions are connecting at the same points, because here we have reaction in this direction, and here also the reaction in this point. So we don't have any points that all supports reactions are concurrent at. So this beam is not externally unstable. However, if you started to apply any force here, what will happen? The beam will start to deflect here because of this internal hinge, and this roller will start to move laterally in this direction. So we are going to have this shape, which means that this beam is internally unstable. So how can we identify if the beam is internally stable or not? To check the beam internal stability, we rely on those three equations here, which is R equal Q, means that the beam is stable and determinate. R is bigger than Q, which means that the beam is stable and indeterminate. R smaller than Q means that the beam is unstable, where R is the number of the reactions, which depends on the type of the supports you have in your structure, and Q is C plus 3, where C is the number of conditions, which equals 1 for internal hinges and equals 2 for internal rollers. For a beam to be determinate, which means that you can calculate the reactions of the supports using only the three equations which we know, which are sigma moments at any points equals 0, sigma forces in y direction equals 0, and sigma the forces in x direction equals 0 also. So let's check an example on this. Here we have this example, and we want to determine the stability and the determinacy of this beam. So let's start as we have just explained. First, we will calculate the number of the reactions. Here we have horizontal and vertical reactions because this is a hinged support. And here we have three reactions because this is a fixed support. So we have horizontal, vertical, and a moment reaction. This means that R equals 5, which is 2 plus 3. And C, which is the number of conditions, equals 1 because we have only one internal hinge. This means that Q equals 3 plus C equals 4, 3 plus 1. And we know that R equals 5. This means that R is bigger than Q, which means that the beam is stable and indeterminate to the first degree. It is first degree because R minus Q equals 1. If it was 2, for example, it will be the second degree. If it is 3, it will be the third degree, and so on. So the answer here is number 3, which is stable and indeterminate of the first degree. let's check another example here. We have this structure. We have here hinged support, and a roller and intermediate hinge. So we have here two reactions, one reaction and two reactions, which means that R equals 5, which is 2 plus 1 plus 2. C equals 1 because we have only one intermediate hinge. So Q equals 3 plus 1 equals 4. So this means that R is bigger than Q, and it is bigger with only one difference. So the beam is stable and indeterminate to the first degree. So this is the answer, which is the third option here. So now we are done with the beam's stability and determinacy. What about frames? Frame's stability and determinacy is checked using these formulas here, which are 3m plus r equals 3j plus c, means stable and determinate. 3m plus r is bigger than 3j plus c, stable and indeterminate. 3m plus r is less than 3j plus c, which is unstable. This is where m is the number of members, c is the number of internal releases, r is the number of reactions, and j is the number of joints. So let's have an example on this. So let's check this example here. We have this frame and we want to calculate or to check the stability and determinacy of this beam. We will start as explained by first calculating the number of the members. We have 1, 2, 3, 4. You need to take care that this is considered as two elements now, or two members, because they are separated by this intermediate hinge. So number of members, which is m, equals 4. After that, the number of reactions. We have here one reaction because this is a roller. We have 3 here because this is a fixed support. This means total number of 4 reactions. Number of joints is 1, 2, 3, 4, 5. Any connection, either internal or external, are all considered to be joints. So we have 1, 2, 3, 4, 5. And finally, the number of internal releases is only 1 because we have only one intermediate hinge here. This means that 3m plus r equals 3 multiplied by 4 plus 4 equals 16, and 3j plus c equals 3 multiplied by 5 plus 1 equals also 16. So this means that 3m plus r equals 3j plus c, which means that our beam is stable and determinate. So this is our answer, which is number 2 here. So this is it for our video today. See you in our next video. Thank you.